first off, we want to use the data in the table to approximate G prime of 3. Well, that's just the average rate of change between 1 and 5. We can't get the instantaneous at 3, we'll just approximate it. So G prime of 3 should be approximately 20.5 minus 15.1 over 5 minus 1. Which, what is it? That's 5.4 divided by 4, which ought to be 1.35. Using correct units, interpret the meaning of it. The correct units are cubic feet per minute, or feet cubed per minute squared. And the interpretation is that this is the rate. So we're taking the derivative of the rate at which the grain is added. So the rate at which the grain is being added is increasing at 1.35 cubic feet per minute per minute. Good or no?
And then do you have to specify at t equals 3, or is that assumed?
If you, yeah, you don't need to write that. Yeah, that's fine. I mean, you could, but I don't think it's necessary. No, do not say the acceleration of the rate, or don't say the acceleration of the grain. They want to know, like, within the time. Acceleration has nothing to do with this per se. Like, there's no acceleration on the grain rate. Even though, I mean, yeah, technically the derivative of your rate is an acceleration, but they don't want to see the word acceleration. All right, part B. The total amount of grain that is added ought to be just the integral from 0 to 8 of g of t dt. That's 1 point right there. And then we're going to approximate that using a right Riemann sum with 4 subintervals. So it'll be 22.7, the furthest right, times the length of that subinterval, which is 2. And then plus 18.3 times the length of that subinterval, which is 1. And then 20.5 times the length of that subinterval, which is 4. And 15.1 times the length of that subinterval, which is 1. And that came out to be 160.8. One more point for this, one more point for this. Good or no?
Great.
Yeah.
All right. Here's the part where we talk about how horrible this grain silo is. The grain in the silo is spoiling at this rate. So within our first 8 minutes, some of this grain is going to have spoiled. We want to know how much unspoiled grain is remaining at t equals 8. Well, that ought to be how much there was at t equals 8 and how much was there at t equals 8. There was 160.8 plus whatever the initial was. Well, the initial was 0, right? It was empty at the beginning. So this ought to be 160.8 minus the integral from 0 to 8 of w of t dt, the amount that spoils. And that came out to be 61.479. And this is where we realize that this is the worst grain silo in history, that we put 160.8 cubic feet in it, and 8 minutes later, almost 100 cubic feet of it had spoiled already. Yeah, usually the answers are fairly realistic. This one is just absolutely absurd. I mean, yeah, doesn't make any sense whatsoever. But that's the answer. 1 point for using the integral, 1 point for the answer. Everybody good with that? Okay. And for part D, we want to know, is the amount of unspoiled grain increasing or decreasing? So that would be what is the rate at which it's being put in minus the rate at which it is spoiling. So G of 6 minus W of 6. If this is positive, then it's increasing. And if it's negative, then it should be decreasing. So that came out to be 2.236827, which is greater than 0. And we'd say since that rate is positive, the amount is increasing. Good. Any questions there on that one?
Okay.
Great. The snail. So first we want the acceleration of the snail. Probably not very fast. At 5. So v prime of 5 ought to be the acceleration of the snail at 5. Your calculator will evaluate that derivative for you. Your calculator will hopefully tell you that that derivative is 0.538. Good or no? Hopefully. Yeah. Okay. That was workable. Part B, what is the displacement of the snail? So we're talking displacement, not total distance traveled, which means we just need to integrate the velocity from 0 to 15. And what did that come out to be? Hopefully 76.043074. Everybody good with B? A and B should have been pretty easy. B was worth 2 points. So an easy 3 points there for that question. All right, part C. When is the snail's instantaneous velocity? So when does this equation equal the average velocity? Well, what's the average velocity? It's 1 over b minus a times the integral from a to b of v of t dt. Well, we already have that value from here, so we just need to divide this thing by 15 and set that equal to v of t. So when you take 76.043074 and divide it by 15, you ought to get 5.069538 is equal to 1.4 natural log 1 plus t squared. You'll graph y equals 5.069538. You'll graph 1.4 natural log of 1 plus t squared. You will use your calculator to determine where they intersect, and you will say that that occurs at t equals 6.031 minutes. Good or no?
Good.
Anybody, any questions on A, B, or C before we move on to D? Everyone's good? All right, part D. We have an ant. An ant has arrived at the snail's starting position, but at t equals 12 follows the snail's path. It goes in the same direction. It has a constant acceleration of 2 inches per minute. We know that after those 3 minutes from 12 to 15, the ant has caught up and is right by the snail. So they're at the same position at t equals 15. We are trying to figure out what the ant's velocity is when it first starts. So at t equals 12. So first off, if the acceleration is 2, we should be able to integrate that to get that the velocity ought to be 2t plus some constant. And if the velocity is 2t plus some constant, we should be able to integrate that to get the position function. And we'll call these acceleration of the ant, velocity of the ant, position of the ant. So the position of the ant ought to be t squared plus that constant times t. And what we're going to do is, since we know that the ant ends up at the same place between 12 and 15, we're going to, after those 12 to 15 seconds, we're going to do this as a definite integral from 12 to 15. Because if we do that, that should tell us that the total amount, we know that this total amount should equal what? Should equal the total displacement of the snail. So we should be able to set this integral equal to 76.043074, which ought to give us that is equal to 225 plus 15t minus 144 minus 12t. And you should be able to solve that for, oops, not t, c, those should be c's. 15c minus 144 minus 12c. And that should give us a value for the constant. That's just some basic, arithmetic. Comes out to be negative 1.652309. And if that's our constant, we want to figure out the velocity at 12. Well, that ought to be 2 times 12 minus this 1.652309, which comes out to be 22.348. Any questions on that process for that one? Any questions, any issues there? Everyone's good? All right, so real quick here, Mark, I'm gonna pull up that one you were asking about. And I'm just gonna sort of write it out. So Mark was asking about one of the multiple choice from last week, which was the integral from 1 to b of x squared dx is equal to the limit as n approaches infinity of the sum from k equals 1 to n of 1 plus 2k over n squared times 2 over n. And we want to know what value of b makes that true. And so this is, we did a whole worksheet on these way back a long time ago, probably during quarter 2, where we were turning definite integrals into this limit notation. And the limit notation, the basic form of the limit notation is always this. It's always the limit as n approaches infinity of the sum from k equals 1 to n of f of x sub k times delta x, where delta x is always equal to b minus a over n, and x sub k is always equal to a plus k delta x. So these are the two formulas you need to know. We got these by taking right-Riemann sums and summing them infinitely together to find these values. So we can see that what we've got here is something inside of here squared. Well, that's our f of x, right, is x squared. So our x sub k needs to equal 1 plus 2k over n, which seems to make sense because that's what our a should be. Right? A should be 1 plus 2k over n. And that this right here ought to be our b minus a over n. Well, that ought to, right off the bat, tell us that if a is 1, b ought to be, what does b need to be? B ought to be 3. And that should give us 2 over n, and it should give us 1 plus k times this 2 over n. So b equals 3 is the only option to make this delta x equal to b minus a over n. Does that make sense, Mark? And everybody?
Yeah.
Cool. Anybody else have any questions on that?
This is from the multiple choice last week, right?
Yeah, I believe it was number 30. I believe is what it was. Yeah. Yep.
Okay, thank you.
Yep. Anybody else have any questions on anything in particular right now?
Actually, could you go through number 5 from that same, from the same like assignment?
Yeah. Let me see here. Give me 1 second. I don't actually have it open right now, so I gotta pull it up.
Okay, that's all right.
Number 5 of the multiple choice or number 5 of the free response?
Multiple choice.
Okay. Is that the 4x cubed minus x to the 4th one?
Yeah, that one.
Just making sure. All right. So let's do this one real quick. Our function is 4x minus x to the 4th. We want to know when it's concave up. So first we'll find the derivative, which will give us 12x squared minus 4x cubed. But concavity only comes from our second derivative. So we'll take a second derivative and get 24x minus 12x squared. And to figure out when it's concave up, we first need to figure out when that equals 0. We can factor a 12x out of that to give us 2 minus x. And then this equals 0 when x is 0 and when x is 2. And so we make a sign chart with 0 and 2 on it. We test something between 0 and 2, like 1. We plug in 1 to this. This comes out to be 12 times 1, which is positive. So it's concave up between 0 and 2, which pretty much tells us that it's choice C immediately. But we could check the others anyway. If we plug in 3, we get 36 times -1, so concave down. So that's negative. And plug in -1, you end up with a -12 times a +3, which is negative, so it's concave down from negative infinity. Does that make sense?
Oh, I see. Oh, yeah. For some reason, I chose A, which has the -1, so I think I misread it.
Yeah, perhaps. Yeah.
But yeah, but thank you.
Other questions on anything? We have a question on quiz 8. Okay, what's your question on quiz 8? I don't know. What was quiz 8 part C? Okay, so first off, to find the integral of that, you just got to integrate it. So the integral of 2x is x squared. The integral of 3f prime of x is 3f of x. And if the integral of f prime is just f, and the 3 is just a constant, so that's just multiplied by the prime. And so then we're evaluating this from 1 to 10, which gives us 100 minus 3f of 10 minus 1 minus 3f of 1. And I don't have the chart in front of me, but what was the value of f of 10? So minus 3 times negative 6, so 100 plus 18. I'll write this over here. F of 10 was negative 6, and what was f of 1? 3. So 100 plus 18 minus 1 minus 9. Looks like that's 118 plus 8. $126. That's what you got. Then you got it right. Where does it say you got it wrong? All right, now I have to go look at Emily's quiz. Hold on. So we're looking at this limit as x goes towards infinity. If we plug in infinity, we'll note that this ends up being a negative infinity in the numerator and a positive infinity in the denominator. So you can use the rule on it. It becomes the limit as x approaches infinity. The 10 goes away. You'll end up with negative 12x. The 5 goes away, and you'll end up with 3 e to the x, which is still negative infinity over infinity. So you can use L'Hopital's rule again. You get the limit as x approaches infinity of negative 12 over 3 e to the x, which is negative 12 over infinity, which is 0. Does that make sense?
Okay, yeah, that does. All right, thank you.
Anybody else? Any other questions?